Hello children, good morning. Welcome to my class. In this session, we will learn Kirchhoff's second law or voltage law. We will do few numerical problems and important numerical problems given in your textbook. Here is a sum. Find the loop equation for the potentials in the given circuit. Observe this one. This is the circuit given. This is the closed loop. See the loop. A, B, C, D, E, F. Next, another loop. F, E, D, G, H. Next, a big loop is there, that is A, B, C, D, G, H. Okay, altogether 3 loops are there. As I told you earlier, see, while moving in the loop, within the loop, you can choose either the clockwise direction or the anti-clockwise direction. For my convenience, I have taken in the clockwise direction. Next, at the same time, you have to remember to list out all the components present in the loop. See, in the loop, observe this one. In the loop A, B, C, D, E, F, observe this one. How many components are present? See this one. In the loop A, B, C, D, E, F, how many components are present? V1, that is a voltage source is present. Next, a resistor R1 is present. Next, observe this one, another resistor R2 is present, and a potential source, that is a voltage source V2 is present. Altogether 1, 2, 3, 4. 4 components are present. Next one, another task, what you have to do, you first identify the direction of the current in the given loop. See this one. This is the direction of the current. It is given in your textbook. You are moving in clockwise direction. Observe this one. Keep the clockwise arrows here. Okay. See here the clockwise arrow is along this direction. Next here. Next this is the clockwise arrow. Okay. Next you have to remember one thing. At the battery. Observe this one. At the battery. See, the current always flows from positive terminal to negative terminal. So, this is the direction of the current at the battery. Okay. Now, if you consider the loop A, B, C, D, E, F, see this one. A, B, C, D, E, F. This is the loop. Observe this one. I1 current is coming out from the voltage source V1 and I2 current is coming out from the voltage source V2. Next, observe this, this is a junction or a node. At F there is a node or junction. So this I1 current and I2 current mixes together and they become I1 plus I2 and they flow through the resistor R3. Okay, so first you consider this loop. In the loop A, B, C, D, E, F. See this one. V1, the potential difference is V1. Next, here as for Ohm's law, the potential difference is V is equal to IR. This is I1 current is flowing, so I1 R1. Next, here it is I2 R2. Next, here it is V2. Now, the algebraic sum of all the potential differences across various components in a closed loop is equal to 0. This is Kirchhoff's second law or KVL. Now, see this one. This is the direction of the current. Next, we are moving in along the clockwise direction. So, this is both the arrows are in the same direction. So, this is plus V1. Next, observe this one. This is the direction of the current at R1 and this is the clockwise arrow. So, both the directions are opposite. So, minus I1 R1. Next, see this one. The clockwise direction arrow is like this in this direction and this one, see this one, the current is flowing in the, see this carefully, the current is flowing in the same direction. So both are in the same direction. So this is I2 plus R2. So the algebraic sum of all the potential differences in this loop is equal to 0. Are you clear about that one? Now this is the clockwise direction, but the current is flowing in the opposite direction. So both the arrows are opposite. So I have written minus V2. So their algebraic sum is 0. Next, consider another loop. See this one. observe this, F E D G H. See this one once again, F E D G H. This is another loop, second loop. In this loop, list out the components present here. So what are the components? V2 is present and resistor R2 is present, another resistor R3 is present. Next, the current flowing along the resistor is I1 plus I2. Observe this one, this is the direction in which we are moving, that is in clockwise direction we are moving in this loop. Okay, keep the clockwise arrows at various components present in the loop. At this component, this is the clockwise arrow. Next one, here observe this one, see this is the resistor R2, the direction of the current is along this direction. We are assuming in the clockwise direction, so both are opposite. Next one, here you observe this one, R3, at R3 the direction of the current is opposite, but this is the direction in which we are moving in the clockwise direction, both are opposite. So the algebraic sum of all the potential differences, that is V2 minus, as for Ohm's law, V is equal to IR, that is I2 R2. Next one, see this one, the current flowing along the resistor R3 is I1 plus I2. So minus I1 plus I2 into R3, as for V is equal to IR. So the algebraic sum of the potential differences is equal to 0 here. So this is the second loop. Next, come to the big loop here. Okay, what is the another loop? A, B, C, look carefully, G, H, A. This is the closed loop and this is the final loop. Next, what are the various components present here? A voltage source V1 and a resistor R1 is present. Next, another resistor R3 is present, and see this one, the current flowing through R3 is I1 plus I2. Here the current flowing through R1 is I1. Are you clear about that one? Next, the algebraic sum of the potential drops in this loop is equal to how much? It must be equal to 0. Now observe this one, this is the direction in which we are moving within the loop. So this is the clockwise arrow. Next, observe this one, the direction of the current in the battery is from positive to negative terminal. So both are in the same direction, so plus V1. Are you clear about that one? Next one, see this one, this is the direction of the current. Observe this one, arrow, this is given in your textbook, this is the direction of the current, but you are moving in the clockwise direction, both the arrows are opposite in direction. So as for V is equal to IR, this is equal to I1 R1, the potential difference is I1 R1. Next, come to this one, R3, the current flowing in this resistor is equal to I1 plus I2, I1 plus I2. Okay, this is the current flowing through the resistor R3. Now as for Ohm's law, the potential difference across R3 is equal to, that is I1 plus I2 into R3. So what is the sign you have to give? Minus, that is negative sign, because this is the clockwise direction you are moving, but the current is flowing in the opposite direction. So both the arrows are opposite in direction. So the loop equation becomes V1 minus I1 R1 minus I1 plus I2 into R3 is equal to 0. So this is the loop equation for the potentials in the given circuit. Are you clear about that one? Now let us do another important sum. See this one. From the adjacent figure, find the electric current drawn from the battery of EMF 12 volts. This is the circuit given. It has given in the textbook. This is the circuit given. This is the battery of 12 volts. You are asked to find how much current is flowing through the closed loop, or how much current is drawn from the battery of 12 volts. Are you clear about that one? See this one. First, assume this loop F E D A F. Observe this one. In the loop F E D A F, observe this carefully. Okay, F E D A F. In this loop, see this one, a resistor of 4 ohms is present, another resistor of 3 ohms is present, and a battery of 12 volts is present. So altogether 3 components are present here. 3 components are present. So let us assume we are moving in this clockwise direction in this loop. This is the clockwise direction. Are you clear? Okay, next, observe this one. This is the direction of the current. This is the direction of the current. If you observe this circuit carefully, at D and A, observe this one, at D and A, there is a junction or a node. There is a junction and node. So I2 current is entering. Okay, next one, I1 current is entering along this direction. Okay, both are flowing through the resistor of 3 ohms. Observe this one. Okay, I1 plus I2 current is flowing. Are you clear? Again, there is a junction. So this current is divided. It is flowing along this direction, and I1 is current is flowing in this direction. Okay, are you clear about that one? Next one, through the battery. Observe this. See this one. Here there is a resistor of 2 ohms. There is a resistor of 2 ohms and a battery is there whose EMF is 5 volts. Are you clear? First let us consider this loop. See this carefully. F, E, D, A, F. Let us consider this loop. Next, here at the resistor, the potential difference is V is equal to IR. How much current is flowing? I2 current is flowing. Next, what is the resistance? 4 ohms. So 4 into I2 is 4I2. Next, observe this one. Next, another component with resistance 3 ohms is present here. So how much current is flowing? I1 plus I2 current is flowing. So the resistance is 3 ohms. So as for Ohm's law, V is equal to IR, that is 3 into I1 plus I2. Why I have given positive sign here? Listen to me. See, this is the direction we are moving. This is the clockwise direction we are moving, and the current is also moving in the same direction. So you have to write positive sign. Are you clear about that one? Next one, observe this one. At the battery, I already told you the direction of the current is from positive terminal to negative terminal, but we are moving in the clockwise direction. Both are opposite, so minus 12 volts. So algebraic sum of all the potential drops across 3 components present in this loop is equal to 0 as for KVL. So let it be equation number 1. Now solving these two, see this one, 4I2, 3 into I2 is 3I2. 4I2 plus 3I2 is 7I2. Next 3 into I1 is 3I1. So this is equal to 12 volts or 12. Simply you can write algebraic sum is equal to 12. Now come to the point. Next another loop. Let us consider another loop. What is another loop? AD. See this one. C BA, AD, CBA. Okay, consider this loop. In this loop, what are the components present here? See this one, a resistor of 3 ohms is present, a battery of 12 volts is present, and another resistor of 2 ohms is present, and a battery of 5 ohms is present. Okay, applying the loop law, that is KVL, to this loop. What is that loop? ADCBA. So 12 minus 3 into I1 plus I2 minus 2I1 minus 5 is equal to 0. Why it is minus 3 into I1 plus I2? Observe this one. See this one. At the battery, the current always flows from positive terminal to negative terminal, but you are moving in the clockwise direction. So both the directions are opposite. So it becomes minus 3 into I1 plus I2. Next, observe this one. This is the direction of the current. See this one. Next, you are moving along this direction, that is clockwise direction. So both are opposite here also. 2 into I1, the current flowing is 2I1. Now see this one. Next one, here this is the direction of the current from positive terminal to negative terminal, but you are moving in the clockwise direction. Both are opposite. So this is minus 5. Simplifying these two, how much? Observe this one, minus 3I1 minus 2I1, that is minus 5I1. Next one, minus 3I2 minus 3I2. 12 minus 5 is equal to 7. Okay, so by simplifying you will get 5I1 plus 3I2 is equal to 7. Let it be the equation number 2. Are you clear? So it is very easy to solve the problems. First you list out the components present in the closed loop and write the clockwise arrows. After that, find the direction of the current. Okay, if both the arrows are in the same direction, write positive sign, and if they are opposite, take the negative sign. It is very simple. Solving equation 1 and 2, see this one. How much you will get? 15I1 plus 35I2 is equal to 60, and okay, if you solve these two linear equations, I2 is equal to 1.5 amperes and I1 is equal to 0.5 amperes. So total current flowing is 2 amperes. Okay, I think children, I made the concept crystal clear. You can solve many problems, okay, if you have an idea how to write the positive and negative signs. Okay, right. Thank you, children.